Hi guys, my name is Ibrahim Abbas. You are welcome to Physics Solution, and I'm super excited, enlightened, and delighted to have you with me here. Stay tuned as we start our lesson today.
The first question we'll be solving says that a body formally from rest at 6 meters per second square for 8 seconds and then decelerates uniformly to rest in the next 5 seconds. Sorry about that. The magnitude of deceleration is deceleration. No, it's not. The question is a very interesting one, and it's very simple to solve. So the first things you realize here is that I've actually highlighted all the major information in the question, which I want you to take a good look at. Now, I've also drew a diagram here to represent the question for us. You realize that the first parameter we're given, it says that a body accelerates from rest. So since it is starting from rest, the initial velocity, which we represent with the letter u, is equal to 0, and the acceleration is what? 6 meters per second square. That is the a. Then for 8 seconds, that's the time for the acceleration. So the time there is 8 seconds. Now you can see that diagram also. It depicts that the body starts from a velocity which is 0 meters per second, which is from rest, and upon reaching a particular time of 8 seconds, it then decelerates uniformly to rest. So we are being asked to find the magnitude of that particular deceleration, and the deceleration takes how many seconds? 5 seconds. Now let's solve. So since we know our acceleration to be 6 meters per second square, so the body accelerates for 8 seconds. Now since we know our acceleration and time, then we have to get our final velocity. So the final velocity from our equation of motion, v equals to u plus at, where our v is the final velocity, our u is the initial velocity, the a is the acceleration, and the t is the time taken for the acceleration. So the v equals to, our u is 0, then the acceleration times the time, so that is 6 multiplied by 8. That will give us a final velocity of 48 meters per second. So the v on the graph there should be 48 meters per second. Now if that is the case, we know that after the object attained that particular velocity, it now decelerates back to rest. Since it is now decelerating back to rest, the position that it attained, it is now its new initial velocity. So that 48 meters per second is now the new initial velocity, and upon reaching the rest position, that rest position is now its new final velocity. Now if that is the case, we have it that for the second phase of motion, the initial velocity is now 48 meters per second, and the final velocity will now be 0. Then the time it takes to decelerate to rest is 5 seconds. So we have been asked to find the acceleration during that period. But since it is coming to rest, we do not call it acceleration, we call it deceleration or retardation. So we will also use the same formula we used, but with our different parameters. So in this case, our v is 0, so our u is 48. So upon making a the solution formula, you will have minus a equals to u over t. It is minus because it is a negative acceleration. It is coming to rest. It is retardation or deceleration. So when you divide your 48 by 5, you will have minus 9.6 meters per second square. So the minus there represents the retardation. It is a negative acceleration. So that is our answer. So welcome back. This is the second question which we'll be solving today. So the question says that a body of mass 25 kilogram moving at 3 meters per second on a rough horizontal floor is brought to rest after sliding through a distance of 2.5 meters on the floor. Calculate the coefficient of sliding friction. So the parameters we are given here, we are given the mass to be 25 kilogram and it is moving at a velocity of 3 meters per second on a rough horizontal floor. This mass is now brought to rest after sliding through a distance of 2.5 meters on the floor. So we are being asked to find what the coefficient of sliding friction. We will take our acceleration due to the gravity to be 10 meters per second square, and we know that the frictional force is equals to the coefficient of static friction multiplied by the normal reaction. Before we can get the coefficient of sliding friction, it is necessary to get our acceleration. From equations of motion, we have v squared to be equals to u squared plus 2as, where our v remains our final velocity, our u is our initial velocity, and our a is our acceleration, while our s is our distance covered. Because the body is being brought to rest, the final velocity is 0, while our u, which is the initial velocity, is 3 meters per second. To get our acceleration, we divide both sides by minus 2s, and our acceleration will become minus u squared over 2s. In solving further, our acceleration will be equals to minus 1.8 meters per second square. The minus there also signifies that the body is decelerating. Upon getting our acceleration, it is necessary to get our retarding force. Now, to get the retarding force, we say our F is equals to ma, and we know our mass to be 25 kilogram multiplied by our acceleration to be 1.8. Therefore, our force will be equals to 45 Newton. Also, we know that our R is equals to mg, where m is 25 and g is 10. Our R, which is the normal reaction, will be equals to 250 Newton. And from our frictional force, we know that frictional force is directly proportional to our normal reaction, where the mu is the coefficient of static friction, or it could also be the coefficient of dynamic or kinetic friction. So the coefficient of static friction in our case here will be equals to F over R. The F being the frictional force and the R being the normal reaction. The frictional force is 45 Newton and the R is 250 Newton. So that will give us and will result to a coefficient of sliding friction which will be equals to 0.18. It has no unit because it is the ratio of two forces.
Thank you so much for staying with me to this very end of the class. I believe you've gained one or few things from this lesson today. Endeavor to watch the video over again for more clarification. Feel free to drop your questions in the comment section below or send to the email below. I so much appreciate your attention. Endeavor to subscribe to my channel. See you again.